Autophagy is a vital cellular process that acts as the body's internal cleanup mechanism, breaking down and recycling damaged proteins, lipids, and organelles. It becomes increasingly important with age, as cells accumulate oxidative damage and metabolic waste that would otherwise impair function or trigger disease. While fasting, caloric restriction, and low-carbohydrate diets are known to activate autophagy, the quality and efficiency of this process are significantly influenced by the oxidative environment within the cell. This is where antioxidant vitamins, particularly vitamin C and vitamin E, play an indispensable supporting role. As cells initiate autophagy, they undergo heightened metabolic activity, especially in the lysosomes and mitochondria. These organelles are central to breaking down cellular debris and often the very sources of reactive oxygen species, ROS, themselves. While moderate levels of ROS act as signals to trigger autophagy, excessive ROS can overwhelm the system, damaging DNA, lipids, and proteins faster than the cell can remove them. Over time, this contributes to cellular aging, inflammation, and the failure of autophagy to keep up with the burden of intracellular waste. This oxidative stress is one of the core drivers of aging and degenerative diseases, and it's where vitamin C and E help restore the balance. Vitamin C, or ascorbic acid, is a water-soluble antioxidant that functions both as a direct ROS scavenger and as a cofactor for several iron and copper-containing enzymes involved in cellular repair and collagen synthesis. Within the autophagy cycle, vitamin C protects lysosomes and endosomal membranes from oxidative rupture, thereby preserving the compartmental integrity required for autophagic degradation. It also modulates redox-sensitive signaling pathways like AMPK and NRF2, which in turn influence autophagic gene expression and cellular resilience. Furthermore, vitamin C contributes indirectly to autophagy through mitochondrial protection. By reducing mitochondrial ROS production and enhancing electron transport chain efficiency, it helps prevent mitochondrial damage that would otherwise stimulate dysfunctional autophagy or trigger apoptosis. In aged cells, where mitochondrial fragmentation and dysfunction are common, vitamin C ensures that autophagy remains a constructive, rather than destructive, process. This becomes especially relevant under fasting or nutrient-restrictive conditions, where cells are already stressed and vulnerable to redox imbalance. Vitamin E, a fat-soluble antioxidant, complements the role of vitamin C by safeguarding cellular membranes from lipid peroxidation. As autophagosomes and lysosomes form and fuse during autophagic flux, the integrity of their phospholipid bilayers is crucial. Lipid peroxides generated by mitochondrial ROS can compromise these structures, leading to leakage of lysosomal enzymes and cellular damage. Vitamin E prevents this by neutralizing lipid radicals in the membranes, stabilizing their structure, and reducing inflammation and cell death triggered by oxidative damage. The interplay between vitamin C and E also improves autophagic efficiency at a systemic level. Vitamin C regenerates oxidized vitamin E back into its active antioxidant form, maintaining a protective cycle across both aqueous and lipid compartments of the cell. This synergy ensures that both cytosolic and membrane-bound ROS are neutralized, allowing autophagy to proceed in a controlled and non-damaging way. In aging populations, where both autophagy and antioxidant capacity decline, ensuring sufficient intake of these vitamins becomes even more critical. Oxidative stress increases with age due to cumulative environmental exposure, metabolic dysfunction, and reduced mitochondrial efficiency. At the same time, absorption of vitamin C can be compromised due to gastrointestinal changes, and dietary fat avoidance can reduce vitamin E intake. This mismatch leaves many older adults with subclinical deficiencies that subtly undermine autophagic function over time. Supplementing with well-absorbed forms of both vitamins, not in excess, but to restore optimal physiological levels, can restore the redox environment needed for healthy autophagic signaling. Importantly, vitamin C and E do not seem to inhibit the activation of autophagy under nutrient-deprived conditions. Unlike protein or carbohydrate intake, which can suppress autophagy by activating insulin and mTOR signaling, antioxidant vitamins support the cellular conditions that allow autophagy to proceed smoothly. In fact, in several models of aging and metabolic disease, vitamin supplementation enhances autophagic flux and improves cellular clearance, particularly when combined with caloric restriction or intermittent fasting. The long-term benefits of this synergistic support are significant. Efficient autophagy reduces the burden of misfolded proteins, damaged mitochondria, and senescent cells, factors known to contribute to age-related diseases such as Alzheimer's, Parkinson's, cardiovascular disease, and metabolic syndrome. Antioxidant support during these catabolic states may ensure that autophagy works not only harder but also smarter, reducing unintended collateral damage and inflammation that otherwise accompanies cellular cleanup. In conclusion, vitamins C and E are not merely adjuncts to a healthy diet, they are essential modulators of the redox environment that autophagy depends on. Especially during aging or metabolic stress, they ensure that the process of cellular renewal is effective, efficient, and safe. By neutralizing excessive ROS and stabilizing cellular membranes, these antioxidants preserve the delicate architecture of autophagic machinery and prevent it from becoming a source of damage itself. In an era where anti-aging interventions increasingly focus on autophagy activation, it is equally important to ensure that autophagy is supported by the right micronutrients, especially those that guard against the very oxidative stress that drives both aging and the need for repair.